Okay, this might mess with your brain a little bit, but remember when I showed in the last like 2 videos ago that logs and exponentials are inverses, right? So one undoes the other. Well, just like if you had 3x plus 4 is equal to 12, to get this x by itself, the undoing of positive 4 is negative 4. Whatever you do to one side, you have to do to the other. The inverse of multiplying 3, so let me simplify that. The inverse of multiplying 3 is dividing 3. So then you have x is equal to 8/3, and you did that by using inverse operations. That's what we're going to have to do on these if things don't work out. So before, we still have to get the x by itself. So this thing right here, we have to get by itself. So we're going to have to add 3.9 to both sides. Right? So now you have 11 to this exponent is equal to, looks like 78.9. And I'm going to move this out of the way a little bit. Well, it's not an integer. We don't know what power to 11. We can't just rewrite this as 11 to some, let's see, squared is 121, so it would be 1 point something. We don't know what that is. So this is what we're going to do. The undoing of an exponential it's called taking the log of each side. So, and when we do this, you can just use ln instead of log. But just for the heck of it, for right now, we'll go ahead and, so I'm going to take the log of both sides. And when there's nothing there, that's a base, that's the invisible base 10. Log base is base 10. Then you have to remember laws of exponents. When you raise a power to a power, you multiply. So we just raised a power to a power, so we're going to have to multiply, but when we multiply, that comes out front. So now that's x plus 1 times log 11 is equal to log 78.9. Well, remember, we still want to get this x by itself. It's in parentheses right now. So what we're going to have to do, notice log 11 is multiplying against that parentheses. So the inverse of multiplying is dividing. And we're, all right. So now this can cancel. And now what we have is x plus 1 is equal to all of this stuff. What do we have left to do? All we have left to do is subtract 1. So it's those logs, I'm not going to rewrite it, but you would. So now to get our answer, and we have to round to the nearest 10,000th. So think about 10,000. There are 4 zeros. So after the decimal point, you'll go 4 places. And this right there is the 10,000th place. So what we type in our calculator is outside parentheses and then log 78.9 close, just one close parentheses, divide log 11 close parentheses. Whoops, make sure you hit 11. Close this parentheses now. So we just closed this parentheses. We now have to close that parentheses. So at the end, there should be a double set of right parentheses, and then go ahead and subtract 1. And you get 0.821. It's 167. This 7 will make That 6 round up to 7. And then you put the approximation symbol, just like that. All right, I am going to pause this. Okay, this one's a little bit trickier. So notice it's base 5 that has the exponent. So we have to get rid of everything else, and we want 5 to the 10 subtract 2.8x by itself. Well, just like in anything else, we always, because we're doing things in the reverse order, so we cancel the addition or subtraction first. Since this is add 9, we subtract 9, and that gives us 10. And then notice there's a multiplying 3, so we'll divide both sides by 3. And then we'll have 5 to the 10 minus 2.8x is equal to 10 thirds. And I'm going to move that over. Well, what do you do now? You go ahead and take the log of both sides. And then this exponent, that entire phrase, is going to come down in front, because remember, laws of exponents, when you raise a power to a power, you multiply. So this becomes 10 minus 2.8x. And that can cancel. So we have 10 minus 2.8x times log 5, and then this is log . And then log 5 is attached by multiplication, so we're going to divide both sides by log 5. And then protect this by putting a larger set, because when you end up putting this into the parentheses to figure out the x value is, this right here is its own separate thing. And then when we have 10 minus 2.8x is equal to all of that, well, first thing I'm going to do is subtract 10 on both sides. Ooh, we still have stuff to do. So now this is going to get a big bracket, because now the subtract 10 is part of this numerator. Maybe that's a good way to look at it, is the numerator will have a set of brackets, or in your calculator, a set of parentheses, and then we'll divide both sides by negative 2.8. So x is about, so let's see what we've got. So this is what I'm going to type in the calculator. I'm going to type left parentheses, and then another left parentheses, log 10, don't use fraction button with logs, use divide 3, close that parentheses, then divide log 5, close that parentheses, close that parentheses, and now we're going to close this bracket, so close that parentheses, and then divide negative 2.8. Let's see if I did that right. I did. So x is approximately negative 0. Remember, 10,000th place, 2.67. That's going to make that round up to 2. And then it's always a good idea to go in and double check your answer up there. If you do, whatever this answer is, and if I need to show you the store button, I would use the store and then retrieve the memory when you type it into there, so you know that both sides equal each other. All right, that is it for this one. Solving exponential equations. When you have to take the inverse property. So we solved exponentials by taking the log of both sides.